In this screencast, I'm going to look at this problem here. Given that x is 2r minus s and y is r plus 2s, in other words, x and y are both given functions of r and s, I'm asked to find the second partial derivative, partial d2u by dy dx, where capital U is a function of x and y. It's an unknown function, so that my answer will be in terms of partial derivatives of capital U, because I don't know what capital U is. And if U is a function of x and y are both themselves in terms of r and s, then capital U can also be expressed as a function of just r and s, and it's those partial derivatives that we're asked to leave our answer in terms of. So let's proceed slowly and look first of all at the first derivative, partial du by dx. And I'm going to use the chain rule here. It can be written as partial du by dr, dr by dx, plus partial du by ds, ds by dx. That's the chain rule. And let me just explain what these terms are. These two here I'm allowed to keep in the answer because, as I said, I don't know what capital U is, so they are going to stay in the answer. It's the other two terms that it's important you understand what I do with those. If I've got partial dr by dx, what that means is I'm treating r as a function of x and y. That is implicit when I write down the chain rule. X and y are coupled together as variables. And similarly, if I've got partial ds by dx, that's treating s as a function of x and y. So what I need to be able to do is to find r in terms of x and y first, and similarly s in terms of x and y, so that I can then evaluate these derivatives. And that's fairly straightforward because I can just solve these equations simultaneously. For example, if I keep the top equation as it is, x is 2r minus s, and I multiply the bottom equation by 2, so that 2y is 2r plus 4s, and if I subtract one from the other, I end up with s is 2y minus x all over 5. And similarly, and I'll leave you to check this, r comes out to be 2/5 x plus 1/5 y. So if you're not happy with what I've done there, do please stop this screencast for a moment and verify these two boxed results. They're important. They give me r and s in terms of x and y, which I can then use to insert values into the chain rule. So let me just write the chain rule out again. This is still the first derivative, and I'm then going to have to look at the second derivative after that. So this is the chain rule that I wrote up earlier. And it's these two values that I now can find. Partial dr by dx, I hope you can see, is 2/5 coming from the second boxed result, and partial ds by dx is minus 1/5 coming from the first box result. So now, in fact, I can just write down what this answer is, and I'll write the constant terms first. It's 2/5 partial du by dr minus 1/5 partial du by ds. And that is the first derivative, partial derivative of u with respect to x. And now what I have to do is look at the second derivative, and I was asked for partial d2u by dy dx. And what that means, of course, is differentiate the first derivative with respect to x with respect to y. And so what I have here is I'm being asked to differentiate with respect to y this expression that I've already found. And what you have to remember is that this bracketed expression here is a function of r and s as it stands. We're treating u as a function of r and s. And so therefore I need to apply the chain rule. If I want to differentiate this bracket with respect to y, what I can do is first of all differentiate it with respect to r, and multiply by partial dr by dy, and then differentiate it with respect to s and multiply it by partial ds by dy. So that is applying the chain rule, and some of these results I already have. For example, partial dr by dy and partial ds by dy I have from the boxed results up here. Partial dr by dy up here is a fifth, and partial ds by dy is 2/5. So that's a fifth, and that one's 2/5. And then I just need to evaluate these derivatives. And remembering that I can't actually find these derivatives, all I'm really going to be doing is writing them out in terms of the second partial derivatives. So I'm now just looking at this term here first of all, and what I have is 2/5 the second derivative of u with respect to r minus 1/5 the second derivative of u with respect to r and s. And that is all timesed by partial dr by dy, which I said was 1/5. And if I now, and I'll do this on the next line so that I can have enough room, I'm now going to look at evaluating this second bracket. So what I have is 2/5 the second derivative with respect to s and then r minus 1/5 the second derivative with respect to s squared, and I'm left with the 2/5 outside at the end. And now I'm just going to tidy up this result in the final line. The first thing I can do is take out a 25th, because I have a fifth times a fifth everywhere. So I've got rid of those denominators. And then let's work through term by term. First of all, I've got 2 partial d2u by dr squared. Then I've got 2 of these mixed derivatives. I've got one here and one here. And by the mixed derivative theorem, I can assume that these are the same, that u is sufficiently well behaved that I can put these equal to each other. And what I have from the top line is minus 1 times 1, so I've got minus 1 of them. And then on the bottom line, I've got 2 times 2, so I've got 4 of them. So in total, I have 3 of them. And then at the end, I've got minus 2 of the second derivative with respect to s. And that is my final solution.